Hello and welcome to another free code session. My name is Jason Bach, and I think the idea of this being a tutorial is starting to fall apart. I'm just kind of winging my way through it, but as I said many times before, source generators are not the easiest thing in the world to build. In fact, from my last episode, I basically spent the day just kind of thinking about this in the back of my head and how I wanted to actually do it. Excuse me. The thing I was debating in my head was the fact that a symbol can have all these partial definitions, and you can get the list of nodes where this symbol comes from. The thing that I think that I realized is mostly that node is used for diagnostic purposes. Once you get into the create output, and you can say, like, at this node location, this is what's wrong or something like that. I don't really need that. Either I'm going to be creating a deconstruct method or I'm not. There's no error involved in this. If there's already one there for the number of properties that I find, so be it. I don't have to do anything. Okay, so I think what I'm going to do is we're going to change this to being an I symbol. We're going to keep it generic because what I want to do here is say context.SemanticModel get symbol. Okay, get symbol info for the node, and we want to get the symbol. Okay, so we're going to make it very symbol info that does this might, I think is what I'm saying here. Yeah. In all honesty, I would expect to get one. Now, the semantic model, what is the problem here? Oh, forward the token. Okay. I like that one. It's doing the right thing, which is if you have a token, keep propagating it into callers, and that's the right thing to do. Okay, so now what we're going to have here is a list of I symbols, not nodes. Okay, and now we have this. So what I want to do now is basically get all of the type symbol nodes, and then also all the method symbol nodes, because the methods are the extension methods, and we know that. Okay, so, and the reason we're going to do that is because we want to find, we basically want to find the method symbols. We want to find, like, basically for all the method symbols, grouping them by their types containing type symbol, what this method is. You'll see what I mean in a moment. So the first thing I want to do here is say var types is equal to symbols where the symbol is I named type symbol. Okay. Now what this should give us is an enumeration of, well, it's not really what I wanted. Select. No, I want to say where, but then I got to cast it. There's probably a better way to do this off the top of my head, but can't say select because I don't know whether, if it is, then do that. So anyway, I get all the name type symbols, and this should be a, well, no, it might not be. We want to say distinct and then cast it. Why isn't that not working? Use symbol equality comparator. Oh, okay, you're right. Yep, forgot about that. Symbol equality. This is an important one because when you're doing things with symbols in Roslyn, you want to use the symbol equality comparator. Whenever you have to do equals or anything like that, you want to use this symbol equality comparator.default, and it will do the right thing. Okay, so now we have all of the types here, okay? And now we want to find all of the methods, but we want to group them by type symbol, if that makes sense. And this is where my link skills are never at a high forte. So what I want to do here is say, come on, var methods is equal to symbols where is I method symbol. Okay. And now we want to take these and cast them to an I named No. Method symbol. And who's texting me? God, you're loud. You're like really, really loud when you do that. I mean, I like when my phone does that, but okay, thank you. If it beeps again or buzzes, I'm sure you're going to hear it. So we're going to have the method symbol here. Okay, that's what we want. But now what we want to say is group by. Groups the elements of a sequence according to specified key selector function. What we want to group by is the containing type. Okay, that's wrong. What we want to do is we know we have a method that's an extension method, so it's the first parameter. So when we say it's parameters of 0, we know that to be true. Okay, now what's this going to complain about? Is it also needing the compare? Okay, so symbol, equality, compare, default. And now what should this give us? This is going to give us, I think, a grouping of a symbol to a method symbol. Okay. And that makes sense because, well, we don't want a parameter symbol. We want to say the parameter, its type. That's what we want. Okay. And so now this should give us a group by that. And that gives us a I symbol, the method symbol. We just have to remember now that the group by here, this is giving us a type symbol, but for some reason what it projects out is just a symbol. I believe this is, there's a part of me that goes, I may have to come back to this later and say, is this doing what I think it's doing? But I'm saying I want to group by where the first parameter's type, that's the key, okay? And then group all the method symbols where they have that same type. Now, the reason why I'm going to do this is because I'm going to say, for each var type in types, okay, what I want to do is I want to say, find me all of the extension methods lengths. Okay. So all I'm going to do for the type itself is say, yes, I think that's what I want to do. What just went barreling through Jason's head? What I'm going to say here is var extension, no, not extension, deconstruct parameter counts. It's equal to a new list of uints because we don't need that there, except what I want to do is give it 4 because I think that's a reasonable, I don't think I'd ever get any more than that. The other thing though, what I want to do here is I don't really care if there are any deconstruct methods here or not. What I do want to find out though now here is, does it actually have any accessible properties? Okay. So let's say var accessible properties is equal to on the type its properties, which you can't do. What you can do is say get members, I believe. Yes. And get all of them. And then I think you can say of type I property. I think there's a properties. Yes, there is. That's what I thought. Okay. So I want to get all the members of a property symbol, of type property symbol. And what this should give us is where that property getter. Yeah, this is where I'm. No, we don't need attributes. Get method is not null. And if we get the method is not null, what I'm going to do right now is say is public. That's not right. Okay. And get method is public. Is there a way to say, I think there's an accessibility. Declare accessibility equals public. Okay. To array. There. Okay. Now the reason why I'm doing this is because I want to see how many properties are actually there. And I need to get the count of them. Okay. Now this isn't quite correct. If I say to do accessibility isn't this easy. Yeah, I guess this is where you start arguing in one's head, like I'm doing right now, what would be a proper expectation of a deconstruct. I would assume it would mean accessible to a caller. And of course, what accessible to a caller means is, I think it gets a little tricky. Definitely public is the easiest one. If this is coming from a assembly where internals are visible to, but I want to be very clear here that the things I was looking for before were type declaration syntax, not type. I don't think there's even a type reference syntax. If I come back up here, type reference. No, it's a typed reference. Yeah, this is just declarations. These are things I'm doing in my assembly. I'm not looking to see anything else. So I think in this case, I can't look to say who's calling me and did I make something internals visible to. So actually, I'm now talking myself out of this and saying, I think this is actually exactly what I want. Okay. And so if you don't have any accessible properties, how can you deconstruct it? Like, what other heuristic could you use to say, I want to give an acceptable deconstruct method? So if accessible properties length is greater than 0, which is exactly what we want, thank you, IntelliCode. You actually nailed it on the head right there. Okay. Now what we want to do is say, are there any deconstruct methods either on this type or in an extension method that has this exact number of out parameters? Okay. Because if there's nothing like that, then we don't care, then we can do this. So I actually don't think I need to, yeah, if the accessible properties length is greater than 0 and there isn't any on the type get, and again, some members of type I method symbol itself, where I want to say there aren't any where the name is equal to deconstruct. And actually, now that I think of this, what I want to do is take this and put it into a shared constant. Because I thought I had it somewhere up here too. Yeah, well, I was looking for deconstruct. Okay. Can I say, is it going to be smart enough? I was just doing what I wanted to do. Introduce constant for all occurrences of deconstruct. Yes, that's what I want. And we'll call this deconstruct name. There. And because I'm pedantic, I want to do that. Okay, so we're going to come back down here. We're going to say we don't want to find one that has that length. So if you have accessible properties and you can't find a method where the name is deconstruct and is static, it's not static because it's an instance method, okay? And its return type, it returns void, and all of its parameters are outs. Okay, so it's a name of deconstruct. It is a static. It returns void, and parameters count. Except I want to do a, yeah. This is a P. This is getting, I will clean this up. Don't, P is out. Can you do that? There's a way to do that. I'm forgetting. I've done it in rocks. I had to do it in rocks. It's not a discard. There's a way to say, is that parameter kind? Symbol kind. I don't think it's a symbol kind that I care about. Can we reference by name? Custom modifiers. Contains custom modifier dot. Nope, that's not what I want. Just forgetting off the top of my head how you tell if it is a out parameter. I know you can do it. I've done this before in other ref. Yeah, that's it. Ref kind is equal to ref kind dot out there. So that count is equal to accessible properties dot length. And how far did we go down the rabbit hole with this one? You know, this isn't working, which isn't surprising. Operator cannot be applied to operator type by method. I don't know. That's okay. First of all, let's get rid of one of these parentheses that says I don't need. Okay, you just said I don't need a parentheses here. Or you think I do. I don't know. Okay, so what are we saying? We have to have properties, and we also have to have no method symbols where get members gives you an array of, is this like some type of, can we say any here? Yes, that's okay. We don't find any of these. Say it like English. We don't find any we don't find any methods that have the name deconstruct, that are not static, that return void, and that have all of its out parameters. Well, yes, but all of its parameters need to be outs. So that's technically correct in that a deconstruct has to have all of its parameters be out parameters. So what we want to say here is, let's do this. Parameters.count of the out is equal to the number of parameters that you have. And then the parameters.length is equal to that. There we go. Now we're actually being correct because we're saying all the out parameters, all the parameters have to be outs. And that length has to be equal to what you found. We don't want to find any of those. Okay. So we don't find any of those. And there's one more case. So we're going to push these all out. Okay. And we don't find any methods. And I think what we just want to say two dictionary here. No, that's the key. Okay, I think I'm back on track. I had to look something up and I actually found to lookup, which I'm hoping is going to do what I want. I want to basically do a lookup on where the key is the first parameters type and the value is just the value of the method. Okay. So what I'm adding to this now is saying, see if there are any, and actually I don't even have to do the contains type here. I could just say, and there aren't any methods of that type, because I think what this will do is just give back an enumerable. It should not, come on. Yeah, and we'll say any here, but we're going to do the same thing, except now we want to say, there shouldn't be any where the name is equal to, I know this is kind of struct generator, deconstruct name, and we know, now in this case, we know these are extension methods, so we don't have to, that is one thing I did not check up above here, which is the methods node. It should be returning method node return type. I think there's a way to say, make sure that it's not returning anything, because it shouldn't be. And I didn't check that here. There's like a special type system void. That's kind of what I want, except I want to say special. That type itself. No, that's not what I want. I want to say I don't know if I can do this at the syntax level. This might be a special type is just an enumeration. So this is the type is void. Specifies the IDs of special runtime types. Only types should mean special names and special types emitted names array. So I don't think I can do that here, but I can do that down here. So I want to say here is that I think I did check to say that it is static. I'll come back up there in a minute. I do, so I know that, and the return, it returns void, and this is basically a copy and paste of this, except slightly different. Okay. That is that. That closes that off. And then that closes that off. Okay, except what we want to do here is we want to say that the parameters in here that are out has to be less than 1 because it is an extension method. So we'd have 5 parameters. The 4 need to be outs. The first one, which we've already checked, is a this keyword. We know that, so we don't have to check for that. And that the parameter's length -1 is equal to that. Now I think we're in the case that we're in. So that's what I'm going to do in the next one, is to finally say, okay, you've found a type that has accessible properties, but it doesn't have a deconstruct method that will give you what you're looking for. And of course, I got to test this all out. I may come back in future episodes where I'm trying to test this and go, wow, I've screwed that logic up, but that's again why I say, what is it? Yes, you write tests. So that's something I'm going to do in a future episode, but I think I've got this in place. The one thing though that I want to check is, do I have that anywhere? No, I can't. Can I just do like a public static class string ext, because I want to, and I want to say public static void do this string self. And of course, we're not going to do anything with it. But what I am curious to see is when I go to the syntax visualizer, is there a way to see on the method declaration what its return type is? Because what does it say? A return type is a void, but that doesn't really help much. You know what I mean? It sort of does. Like it says here, if I do method node return type, and that's always going to be not null. Is special type? Is there a way to say, okay, hold on, I'm going to look something up. Okay, look this up. So I'm going to have to remember the link to this for Stack Overflow. But as you'll notice here, and this guy, Jason, he works on the Roslyn team. At least he did, or he still does. But he's basically saying if you do something like this, that's perfectly acceptable to see if the return type does. So you say predefined type syntax, the return type. So that is what I want to do here, okay? So we're going to grab all this and come back up at here. Excuse me. So we're going to say method node here. It's return type. No, whoa. Method node and then NAND. And what does it know like here? Does not equal syntax kind, syntax kind of keyword. That's not necessarily what I was looking for. I mean, yeah, I can see down here you can do return type, but if you're at this point, you might as well just say returns void. The keyword is a syntax token. Its kind, oh, you have to say that. Except now that doesn't work. And he is kind. There. Okay, so the keyword is the void keyword kind. I think that makes sense. So now we actually have the extra filter there, and we do not need to do that down here. We know that we are going to find something that returns void, so we can get rid of one step there. Okay. Could we've already, okay. Yeah, and I just realized I was about to say this. We've already done this part too. All we need to say here is that. And we already know that these are the types. We're only getting deconstruct ones, so we don't even need to do that. Isn't it great when you optimize? So, oh yeah, we have to say that there. Okay, so I think this is actually now, I think this makes sense. One more time, let me go through this. We need to find that the type has accessible properties. If it does, then we also want to make sure that we currently do not have any deconstruct methods on the type itself. And those deconstruct methods should not be static. They should return void. And all their parameters should be out and equal to the same like. We don't want any of those. And we don't find any extension methods, which we've already qualified that they are they got the name deconstruct. They are static. They have the first parameter is this parameter and they return void. So and all of the other parameters are outs. We've already verified that by what we've done up here. We have said that it's a deconstruct, it returns void. It has more than one parameter. The first one is a this, and all of the other parameters after that are this. I guess you could technically say what would happen if I did an out on the this, but I don't think that would even let you do that. Like I can't say out this. Okay, yeah, it doesn't let you do that. Yeah, so that wouldn't even be valid. I guess you could put it in there and we could check for diagnostics. That's probably one, but we've already done all that work. So the only thing we need to do down here is just say that if we found 4 properties, the number of parameters there, if it's 5 minus 1 is 4. We don't want any of those either. So if all those things happen, now we can actually do our code generation to generate a partial static class that will have a deconstruct method for us. But that's what we're going to do in the next episode because we are at time. So thank you all for watching. Leave comments and questions below. See you in the next episode.